All right, please stand. Let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, and the Son, and of the Holy Spirit. Take out, please, your 13C-1, 1 through 4. And friendly reminder, if you're tempted to put fingers on the assignment board, don't. The days that those you get smudged out. There might have been an accident by somebody bumping into it, but be careful. People do need to know that. Have your 1 through 4 out. Let me see what you got. Should be just the front page. And friendly reminder, make sure you have arrows on the tops of the two branches of your parabola, because it does go up and out forever. Alrighty. Let's take a look. Number 1, the vertex should be 3, -4. So 3 spaces to the right, 4 spaces down. Did we do this together?
Yeah, we did the
That looks
first one.
familiar. Okay, the first one. So just for reference, go 3 to the right, 4 down. Then your first jump should be over 1, left and right, and then up 1. That'll give you your first pair of points. So for example, it should be a point at 4, -3, and 2, -3. Then the next pair should be starting at 3, -4, over 2, up 4. So it should be 5, 0, and 1, 0. Does that make sense? Number 2, the vertex should be 3, 1, +3, 1. So 3 to the right. They were actually kind of nice to you because they kind of zoomed in the graph where you're kind of supposed to be. I would have given you the entire 10 by 10. So make sure you don't go -3, 1. So it's +3, 1. So 3 to the right, 1 up. And it's the same pattern. Over 1, both ways, and up 1. Then start over 2, up 4. And then draw your parabola. Number 3 should be a vertex of 2, -1. 2 to the right, 1 down. Then you do over 1, up 1, over 2, up 4. Make sure your parabola goes through the dots that you draw. It's not going to be above or below. It's going to be right through them. And number 4 should be a vertex of -4, -2. So 4 to the left, 2 down. It's -4 because the inside should be minus to make the form work. So x minus -4. So go to the left 4, down 2, there's your vertex, put a dot. And then go over 1, up 1, over 2, up 4, and then draw straight through those points. Does that make sense? And it repeats. Alrighty, good. Take out your notes, please. Let me show you 2 things we're going to do today. One is practice a little bit with height multipliers. And then the second is, how do you graph a parabola that's in non-vertex form? Just to start us off, there are forms of a parabola focused on 1 yesterday. I would like you to memorize this form as soon as humanly possible. Y equals A parentheses x minus h parentheses squared plus k. Maybe tell me what form that's named. What's the name of that form? Go. Vertex form, correct. Why do they call it that? Right, they give you the vertex kind of on a silver platter, h comma k. Just remember, the inside has to be minus, the outside has to be plus, otherwise it won't work. Otherwise you get the wrong numbers. What does the A stand for? What's that do? Go. The height multiplier, correct. A is the height multiplier. Abbreviate here. The height multiplier multiplies the height, hence the name. So if A is 2, it's twice as tall. If A is 10, it's 10 times as tall, which would be the same. But it does happen. There is another form that we have seen before. We didn't focus on it yesterday, but it's this. Ax squared plus bx plus c. Does anybody remember the name of that form? We used it with the quadratic formula. Starts with an S. I'll give you a hint. All the powers, yeah, go. Standard form, correct. Standard form, the one catch is it's not equal to 0, but I'll explain that in about 2 minutes. Standard form is when all the terms are in order from highest power to lowest power, and it's A, B, and C. Okay. Normally it's equal to 0. I'll explain why in just a moment. Actually, I'll explain it now. In algebra, there are 3 things that I'd like you to, the third one is going to look a little mysterious, and it's not really in this chapter. But I definitely want to get you familiar with these 3. This is true no matter what level you go into. Algebra, pre-calc, calculus, all the way up. In algebra, if you have blah, 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 blah equals 0, that's math code for something. If you have it set equal to 0, that's a universal code. Even if you had a mathematician in France or something that didn't speak a lick of English, as soon as they saw blah, 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 blah equals 0, they would think in their head, you're about to solve. Setting something equal to 0 is math code for I'm going to solve this. I mean, do you have to when you set it equal? No, it's a free country. But if it's set equal to 0, everybody's going to expect, person in France, sacre bleu, they are going to solve. So they don't have to understand English. It's math code. Equals 0 means setting it up to solve. Make sense? Now, y equals blah, 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 blah means something else. We've seen that a few times, like slope-intercept form has it. We've done it several other places. And we've done it over here. Y equals, instead of equals 0, it's not solving, it's something else. And we actually did it on the worksheet yesterday. Take a guess. Go, graph it. You're getting ready to graph it. Y equals blah, blah, blah is universal math code for I'm setting this up to graph it. You can be in Germany and not speak a lick of English, and someone says, sees the Y equals, and they say, Achtung, ist graphing. Well, I can't do the German that well, right? But does it make sense? Equals 0, you're solving something. Y equals, you're graphing something. You can use the exact same formula 2 different ways. So if I were to do this, sorry, I forget you can't see it at home. So if I had 2x squared plus, 8x plus, 8. Here's what if I did this equals 0, then you're going to solve it. you'd solve for x. You eventually, any guesses how many solutions you'd get? How many different x's do you get? What was it? 2. What gave it away? There's something in that formula that gives it away. Think back to factoring. Why did you say there were 2 solutions? You're right. If it were just 3x plus 5, I would expect 1 solution. Go. Yeah.
There's 2 species of eggs.
Very close. That's kind of sort of, yes. You're really, really close. Yeah. Power of 2. That's exactly that. Did, you remember, I almost gave it away. What's the nickname for the highest power in a problem? Okay, remember? Like if you have like x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. X to the 5th, the highest power in the whole thing, is a nickname. It starts with a D. In geometry, they use the same word for measuring angles. And in physical science, they use the same word for measuring temperature. Go. Degree. Degree. Degree is the highest power. If the degree is 2, you're going to have 2 solutions. If the degree is 1, you're going to have 1 solution. By the way, that's a universal law. If the degree is 5, guess how many solutions you're going to expect? 5. There are going to be 5 different values of x. They might be icky, but there'll be 5. That's, I don't know if I told you about that. It's a really impressive sounding theorem too. Have you heard something called a theorem before? A theory is something where you're making an educated guess and then looking for proof. A theorem in math is something that's already been proven. Like it's lock solid, guaranteed true. Like the Pythagorean theorem, remember that? A squared plus b squared equals c squared. The Pythagorean theorem, the word theorem means they proved it. Actually, there's like 240 different proofs for the thing. People have proven the thing to death. It's pretty fun. This has nothing to do with anything, but I thought this was amazingly funny. There was, a proof is where you just set up, well, this is the reason why it's true, and sometimes it takes like 2 pages to prove it. Sometimes it takes 100 pages to prove it. Sometimes it takes like 3 lines to prove it. Depends on how complicated it is. The Pythagorean theorem, one of the proofs, one of the 200 plus proofs of the Pythagorean theorem was designed by a president of the United States. He wasn't president at the time, he was in Congress, and apparently there was something really boring going on. There were blah, 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 blah up in front, and he was doodling on the back of his paper, and he came up with a new proof for the Pythagorean theorem, which I thought was absolutely amazing.
That's what the teachers should do.
Yeah.
We can learn more.
I'm not,
What was that?
he was doing it in favor of math, and there was just somebody going blibbity blah 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 up on top. I don't know what they were saying.
Who was the
James
president?
Garfield.
Oh.
James Garfield, and he was assassinated too, which is a shame. I suspect he was assassinated because he was a math guy, but he was too dangerous. So anyway, I just thought that was fascinating. One of the actual proofs that they have in textbooks is used by James Garfield. Mr. President James Garfield, God rest his soul. Anyway, the third thing, did we cover this at all? This is more of an Algebra 2 thing, so I kind of doubt we did. F of x equals blah, 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 means it looks like a function. That's for later. This is more of an Algebra 2 thing. So you don't have to worry too much about that. But the first two are going to show up in this book. Equals 0 means you're going to solve. But if you take the exact same problem, y equals 2x squared plus 8x plus 8, that means you're going to graph it. Does that make sense? Y equals means graph. Equals 0. So if I want to take a graph and then solve it, I would erase the y equals and put equals 0. You can physically do that. Tell you more about that later. But for now, does that make sense? Yeah.
Can you do it to all our problems and not have to graph?
Funny. No.
Please?
Now you have to graph them, in this case. Let's try one, see what it looks like. Example. You know what, let's try this one. graph y equals 2x squared plus 8x plus 8. Now, I will say that if you're absolutely desperate, if your life depends on it and you have no other way to graph, you can use a table, like an XY chart. You can always do that. It takes forever, but that's an exaggeration. It takes a while. You do a chart with a bunch of X's, find the Y's, and then draw a bunch of points, and this one will be a parabola. There is an easier way. Doing a chart is tedious, and you might not even hit the vertex. Like, the vertex might be off screen. If you choose like -2, -1, 0, 1, and 2 for X, you might miss it, because the vertex might be over at X equals 4, and you would never know. Or, heaven forbid, if the vertex is like at 1.5, you'll miss it. You'll never know it goes down that far. How do you get this graphed? The only form we've ever graphed is vertex form. I would love to get this in vertex form. Is it possible? As a matter of fact, yes. How? By something called complete the square. There's a 3-step pattern for complete the square. Somebody recite it for me. Tell me. Maria. What is the 3-step pattern associated with binomial squared?
Square the first, double the product, square the last.
Good. Square the first, double the product, square the last. Let's check these terms and see if they're good or bad. Eric, does this a good square the first? Like, did they square something and get it?
No.
No. I would say half yes, half no. What part is good?
The x squared.
X squared. What part is bad?
The 2.
The 2. Yeah, if it were 4x squared, it'd be perfect. 2x squared, half good, half bad. 8x. Does this look like a good double product? Yeah, what did they double? 4x, yeah. Therese, does this look like a good square the last? Heck no. If this had been 9 or 16 or 25, it would have been good. 8, not so much. So what should we get rid of first? Yeah.
The 8,
The 8. How?
you have to set it equal to 0.
Right. The very first step, and this is the first time we actually had to do this, get it equal to 0. That means physically cross off the y and do 2x squared plus 8x plus 8 equals 0. So this is the first time where the first step actually meant something. Well, I guess we did it a couple of times before, when they had equals 6 and things. What comes next? What do you get rid of first? Andy?
The 8,
Yeah, how's that again? How do you do it?
subtract from both sides.
Yep, and leave what?
1.
Leave a blank. So 2x squared plus 8x plus blank equals -8. So there's step 2. What did you for step 3? Jack Gilbert. What do you still need to get rid of? One of the terms had something good, something bad. The 2. How do you get rid of that legally? Yes, GCF it. Now be careful, it's not a full GCF, because the GCF is actually, let me see it. What's the full GCF?
Could you GCF it first before you subtract it?
Could you do the GCF before you subtract it? The short answer is no, because sometimes this is going to be odd number, and it won't work very well. This is pretty much garbage. We want to get rid of it first, because it's the worst term. So could you, yeah, in this case it was 4, we got lucky. If this were 7, it'd become 7 halves and things like that, and it gets really yucky really fast. So the rule on this, the funny thing is, I want to get rid of this even if it looks perfect. If it were a 9, I'd still kill it. So wait, it's a perfect square. Yeah, it's nice. You just move it over. Why? Because it might not be the right perfect square to match this stuff. As a matter of fact, it probably wouldn't be. So bump it over. Be careful you're not pulling out a 2x. That would be the actual GCF. I don't want to pull out a 2x. I want to undistribute the a, just the 2. So Jack, go ahead and tell me what you get. 2 parentheses what?
X squared plus square.
Yes. then plus
Plus blank,
blank, parentheses, equals
negative
-8. Okay. So there's step 3. Can anybody refresh my memory on step 4? What do you do? Go. Yeah.
You put it in binomial form.
Yeah, put it in binomial squared form. In other words, this parentheses, I want to compress it into a binomial squared. The metaphor I use, I don't know, maybe this is a guy thing, but whenever I'm packing a suitcase, sometimes my wife packs it for me and sometimes I pack it for me. When my wife packs it for me, I don't know what, but like women have this skill of getting like twice as much stuff into a suitcase than a guy does. Maybe I just like, oh, stuff. I don't know. But I do know that when she packs my suitcase and I go to the hotel or something and I unpack, I can't get the bloody stuff back in. It's like, how do you get that? I'm sitting on the suitcase trying to get the thing done. So you have this huge volume and it's compressed into one little area. So if you think of this is like the suitcase open, and this is the exact same value compressed. Okay, so I'm not changing anything, I'm just making it look smaller. That was a weird metaphor, but it's true. What belongs in here? Rosie, take over.
X plus 2,
Yeah, where do you get the x from, first of all?
the x squared.
X squared. Where do you get the 2 from?
The 4x.
Yeah, you undouble, and then tell me what should have been here.
4.
4. Where do you get that?
Square the last.
Right, square the last. There's something that should be there that I didn't write yet. Let me see it. Yeah, the 2 in front. Equals, now there is something else we need to do before we proceed. Rob, take over. I see a 4 here. You can put it there as long as you, what should I write? Is this right or wrong? Wrong, what's missing? Right, everything is twice as big as we thought it was. Ta-da! So what do you actually get?
0.
Yeah, this is 8. Negative 8 plus 8, I know what you meant, is 0. Are you with me? Now, if we were solving, I would say just get the x by itself and we're done. We're not solving. We're graphing. This is, I forget if it was 5A or 5B when I was talking about graphing. Somebody look in the notes, Amelia.
It's 5A.
It's 5A for graphing? Which one? 5A, okay. I'll play with my mind, sir. So 5A is for graphing. And it says get the answer back to 0. You sort of insanely lucked out here. If this had been like a 9, you'd have to subtract it back over. You know what the heck? This really looks stupid, but I just wanted to show people we're actually doing something, even if it looks useless. So 2 parentheses x plus 2 parentheses squared minus 0 equals 0. I normally don't write it like that. Can anybody guess why I am? Go.
Because it's the vertex
The form. I want to get it in the right form. Now, there are a couple things that still need some tweaking. Does anybody see them? Go.
The parentheses needs to be negative.
Yeah.
The
What is it really?
0 should be a plus.
Yeah, true. Yeah, that's totally funny. But what should this be?
Minus.
Yes, minus a negative 2. Because adding a positive is the same as subtracting a negative, and that's squared. And this has to be switched to plus. You can do plus negative 0 if you want to be funny. But I'm just going to put plus 0 if that's okay. Did I freak anybody out? Mr. Conklin just told us that you can always replace subtractions with addition. No, I did not. You know, subtracting $5 from my bank account, that's like adding $5. No, it's not. It only works with 0. So equals 0. It's in vertex form. What are they asking us to do with this thing? What was the original point? Here. Graph it. What's the code for graphing something? According to this stuff. Equals 0 means solve. What's that? Y equals. That means physically drop the equals 0 and put the y equals in front. And we now have the power to graph this thing. Let's see what happens. Can somebody tell me where the vertex is? Catherine, where's the vertex on this thing? What comma what? -2 comma 0, exactly. It's x minus something squared plus something. Those two somethings are the vertex. So -2 comma 0 is like 2 to the left and then don't go anywhere. You put a dot there. Can somebody tell me the normal pattern for a parabola? Andy. When you're graphing a parabola, what's the normal pattern you go? Start at the vertex and go where?
Over 1 up 1.
Over 1 up 1?
Over 2 up 4.
Over 2 up 4. What's different about this one?
It has a height multiplier of 2.
Yeah, it is a height multiplier of 2. The height is twice as tall. What's the new pattern? Go.
Over 1, go up 2.
Over 1 up 2. And then what's the next one?
Over 2 up 8.
Over 2 up 8 instead of 4. Let's try this. I'm going to have to make my graph taller. One second. So over 1 up 2. It's going to look skinnier. That's actually an optical illusion. It's not skinnier, it's just taller. And then over 2 up 3, 4, 5, 6, 7, 8. Over 2 up 8. Put a dot here, and then do the other way as well. And you will have, again, it's kind of an optical illusion, but look, a skinnier looking, much taller parabola. That make sense? So you just handle two things. Number one, complete the square gets it in vertex form. That'll tell you where the vertex is. And then if you have your parabola pattern memorized and know what a height multiplier is, you can go click, 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 click. If it's 3 times bigger, you go over 1 up 3, over 2 up 12, whatever, 4, yeah, 4. Question? Sorry. Oh, okay. Any questions on this? Does this make sense? Feeling okay on this? Take out your worksheet, please. I'm going to give you just a couple of hints, and then I'm going to give you the rest of the hour to work. Number 5, 6, 7, and 8, they're already in vertex form. All you have to do is graph them. Be careful, some of them have height multipliers, actually all of them have height multipliers. A few of them have negative height multipliers. Can somebody refresh my memory what that means? Go.
You go down.
You go down, correct. If it's just plain old negative, it's like -1. So you go over 1, down 1, over 2, down 4. Look at number 6. It has a height multiplier of -2. Can somebody tell me the pattern for that? Just off the top of your head. If they have a height multiplier of -2. Go. Rob.
Oh, you go over 1, down 2.
Yeah, over 1, down 2. How about over 2?
Over 2, down 8.
Down 8, exactly. And that's probably as far as you can go. Does that make sense? On the back page, if you turn over there, number 9, y equals -x squared plus 4x minus 3. There's a -1 in front of the x squared. You will need to do complete the square on that. Get it in vertex form. And number 10, you'll need to do complete the square on it to get it in vertex form. Everybody clear? Yeah, question.
For 8, it would be over 1 up 3. What was the
Correct.
second one?
Oh, good question. Over 2, it's normally what? Over 2 up 4, now it's 3 times bigger.
So you just multiply.
Over 2 up,
6.
well, it's normally 4, and then 3 times bigger. It's a big jump. 12. Yeah, over 1 up 3, over 2 up 12. It's normally over 1 up 1, over 2 up 4, but all the heights get 3 times bigger. The far overness doesn't change. Just over 1 is always going to be over 1.
So, okay.
Over 1 up 3. And if you went over 10, God forbid, you would go up 300, I guess, because it's normally 100. I mean, I hope you have a lot of paper, but yeah, question.
Well, how do you do number 7 again?
How do you do number 7? Pretend there's a -1 in front of the parentheses. That'll give you the height multiplier. That tells you two things. It's a normal height, it doesn't make it any taller, but the negative makes it go down. And you'll have to fix the parentheses sign. That's supposed to be subtraction. Just have to fix it legally. Make sense, okay? Alrighty. That will do it. You have the rest of the hour. You got about 20 minutes, so you may be able to finish this. And if you finish this, you have no homework over the weekend. Congratulations. Yada, yada, yada. I'll be right back. Yes, if there's a negative, if it starts negative, pull out the negative. Murgatroyd phenomenon. Okay, for the people listening at home, your assignment is to finish 13C-1. It's actually, I hate to tell you, I'll rotate it. Ta-da! Sorry. So in the, let's see if I can point. Yeah, there's my finger. So assignment for Monday is 13C-1, numbers 5 through 10. And that should do it. So anyway, this is my hand waving goodbye to y'all. Take care. Bye-bye.